Hello everyone, I'm Mohammed Zakria and I'll be explaining you our ICP5 Big Data Analytics and Applications. We were given this model, we had like 5 classes and some 3700 rows of data of 5 flowers. And we were to basically later on apply CNN and then basically predict the outcomes, and the ICP was all about how can we improve our hyperparameters. Hyperparameters are parameters which are basically hard coded and which we actually insist our model which can be changed, and once fine tuning them actually gives better results. So we'll take you over to from where we started. Initially, when we saw when there was no dense layer, we saw that our in this graph we can see it's overfitting. The accuracy has been converged to 1, so it's like a perfect model. And we also want the training accuracy and validation accuracy to basically go side by side, or there should be a symmetrical pattern between them, right? So few of the parameters which we changed is number one, I added a dropout layer after every max pooling. So what it started to do is, I have mentioned in the report as well, after every dropout layer, once you add this, so you can see that at least it has started to converge a little bit. Okay, so after when I see that it has started to converge, so that's why I added a dense layer, dropout layer. Dropout layer basically drops out majority of your weight neurons, and it keeps the most important ones. Okay, after this, what we did is basically flattened out. Yep, flattening. So flattening is explained over here. So we already added one flattening layer. So I wanted to add another dense layer, which is our hyperparameter 3, and another flattening layer. So the results are very well explained in the report as well. So this was initially obtained with the layer dropout layer, and once I flattened out, you can see the curve has gone a little bit flattened out, and there are no more peaks. Like if there are 5 to 6 peaks here, there were like 7 to 8 here. So flattening actually basically improves our result. And then once I added another dense layer, so it even further flattens out. The fourth parameter which we basically changed is our batch size. So batch size was basically taken as 64 initially, so it was defined at the very start, so somewhere above there. Yep. So initially we changed it to 64, but that did not work. And then the whole procedure was ran before in the ICP, in the class it was ran on 32, so I changed it to 16. That's why if you see our epoch, that is also changed to 184. So we have like 184 batches, and each batch contains 16 images. So lowering our batch size has also increased our accuracy, and it is giving us a lot of stability towards the end as well. Then we tested our model on 4 different images taken from network, so web. So this was initially discussed in class, so I ran all these, and ouch, I need to run again. Let me run this again from here. Oh, I have to run all over it again. So I'll just go through and explain you quickly the other results. Yep. It's a daisy flower, and our model predicted it perfectly right. So it's somewhere here. Yeah, this was the first image which we took, and this was the second image which we took, and this and this. Yep. So these 4 images were given to our code, and it predicted the results in here. Yep. So one was daisy image, tulip was predicted with this accuracy. The other was predicted with 64 roses was predicted with this accuracy, and likewise Daisy, and as well as this. So I just needed to run that, but it's still working perfectly fine. Okay, thank you so much.